Hello everyone, September 29th. Alright, what a day. I'm stuck. Not stuck, there's just a lot of things to do. There's just tons and tons of stuff to do on the test side. You know, I always try to have 100% coverage, and man, is that tough to get to 100% coverage. I think now we're at 98. I mean, all the statements have been covered, but we have a few branches that's still not covered, and the requirement is 100% on the branches as well. So we still have maybe 2 files that need to do. Man, it's just tough. It's very tough. All right, so it's late, so I think I'll just handle this one and then just call it. Yeah, I don't think I have time to dive into this. I'll do it another time. Yeah, tomorrow I have a very important task as well, and we'll see how we can handle it tomorrow. Yeah, tomorrow is going to be, man, one day is not enough. I need at least 2 days. Anyway, let's get this one done. Given a sorted integer array, 2 integers, k and x, return k closest integers to x in an array. Should be sorted. So k and x return the k closest integers to x. So we have x. I want 4 closest. That's 2 or 3 by itself for sure. And then closest to 4. A is closer to x if and if the same, we pick the smaller one. Gotcha. So k is 4. No. X is minus 1. Oh, x is any value. It doesn't really matter. X is any value. I see. So we binary search to get to where they should be. I mean, it could be this. It doesn't matter. We can just binary search it, and then we have to find the k. How long is the k? Didn't really say how long, but we can just do left and right, left and right, left and right, something like that. So if it's in the middle, if it's in the middle, all we have to see, it doesn't really matter. We pick the value and then we go left and right, and then we record the first one, right? And then, the closest, I see. K closest. I mean, we can get them and then we sort again at the end. So that's not a big issue. So what we should do is compare the two, right? So we have here, and then we compare the two. If this, then we move here, compare the two, and then we push whatever, and then at the end I will sort again. Yeah, it's okay. We can sort again when we return. Yeah, I just want to do this as fast as I can, you know. Alright, so in the binary search, I like to use bisect right. So when it's index equals bisect right array and x, right, we get the index. And then starting from this index, we are going to have, two things. Actually, let me think. This index, it doesn't matter. I always point into this one, right? I always point into this one. So what we're gonna do is we have I and j, right? We also have I and j. So we say I, j shall equal to index minus 1 and index. And we say while I is larger or equal to 0 and j is smaller than array, right? We have a result. Say if array I, well, we can do ABS. Actually, I know x minus this is smaller than array j minus x, then rest.append array I, right? And append array I and I minus equal 1. And then elif, say elif this is larger than, right? And rest.append array j plus equal 1. Right? Else, if they're the same, then we say if array I is smaller than array j, right? Since they're the same distance, then we'll do, what if they're the same? Yeah, what if A and B are the same? Good point. What if they're the same? Oh, I guess it doesn't really matter. Oh, but we would put the smaller first. Yeah, we always put the smaller first. We put the smaller first. Well, if they're the same, then it doesn't matter. We just say if this and I minus equal 1. It's okay. And if, oh, we can do else, right? Else, then we do j, then j plus equal 1. So we do that. When we jump out, right? When we jump out, oh, and also we only take k. So while k, and so every time when we're done, k minus equal 1, right? So we jump out, we say if not k, if k, right? Which means we still have, then if k means one of the I or j has exhausted. So we say if k, and we say if, oh, what if we don't have? No, one of them is exhausted. We say if I is smaller than 0, right? Or we can say if I is still larger or equal to 0. So if k, and it means j has exhausted, then we shall take, right, we shall take all, right, we shall take all. So k is smaller, so it doesn't really matter. So we shall take, oh, I can just say while I is still larger or equal to 0, rest.append array I minus equal 1. Now while j is smaller than an array, rest.append array j and j plus equal 1, because only one of them will be right. and then we return sorted res. Do we have? Oh, I forgot the answer. 1, 2, 3, 4. 1, 2, 3, 4. Actually, we have one more test case. As if we have this, right? And it's 1, 3, 3, 4. Oh shoot. Well, k and k minus equal 1. While k and k minus equal 1. So if k is 0, then neither will run. Yeah, looks good to me. And this we can test actually. Yeah, let's run some tests. I like to test myself, especially things like this. I just need random, right? From random port rand int. For this in range, let's take 10. Okay. We're gonna print how long for this in range. Let's do 10. And we have to be sorted. Well, we say rand int minus 100 to 100. Okay, then print rand int k. How many? So we have 10, so 1 to 10. Right, k is 1 to 10. The last one is x rand int minus 100 to 100. Oopsie doozy. Yeah, maybe here. Nope. Oh. There we go. Let's see. All right. Good. Let's run one more. Let's do 100. Okay, so this is right. Shall be right. Yeah. All right, that's it. Let me just do this once. Call it. We probably will take a look at the previous solutions and then, yeah. What is it called? O and login. O and login. $6.58. Binary search and merge sort. Yeah, basically it is kind of merge sort-ish. This is today. This is 63 or 66 or more test cases. Oh, look at that. I see the trick. Binary minus k. Because it has to be continuous. Yeah, so basically we want to find a k length. Okay, so we want to find a k length subarray that everything's closest. So I just need to make sure that the front is if we go the left, so the distance from the left to x must be smaller than the distance one more to the right. Yes. So with binary search, we want to find the left, right? So we will go the middle, and we say the left. Yeah, so we try to find the left, and if the left from here is smaller. Hold on, let me see. X minus array mid. Yeah, we try to see the mid, right? We have the left and we have the mid. We try to see if it fits, right? So we say if the left bound and the right bound, if this one is smaller than this, if it's smaller, that means we can move right a little bit more, right? No. Left bound is the most. Hold on. How? Let me think again. If this is smaller. Hold on. So this is closer to this than this. We compare this and this. What does it mean? If one's on the closest. So if this is smaller than this, that means the left bound can be here. Yeah, because the left bound, we start from 0, right? We start from very much to the left. And we're trying to see if, of course, if this is larger than this, that means it's too much to the left, right? So we need to move to the right. Therefore, if x minus the here is larger than, right? It means like if it's all here, then we need to move the left to the mid, right? We need to move to mid plus 1. And if this is smaller than this one, that means it's too much to the right, right? If it's too much, because it has to be, you know, in the middle. So if it's too much to the right, then we'll move. So if that's mid, and it's too much to the right, then we put right here, we move it in. So if it's in the center, all right, if it's in the center, then what do we do? All right, so the mid is going to be here. Mid plus n is going to be here. And this is smaller than this, right? That means this one's okay. Yeah, this is a good one, right? This is a good one. Then we put right. Oh no, all we do is the left bound. We want to try to find the left bound. Yeah, we try to move to the right a little bit, move to the right a little bit. And if this is smaller, which is this case, then we're going to put the right here. If it's still smaller, hold on. If it's smaller, that means the left bound, we can move more to the left. Ah, I see. Okay. That's a very smart method. We try to find, so first observation is that the returned list must be a subarray of array, because otherwise we won't be having the closest values. So now, second, since we are looking for a subarray of size k, we only need to locate the left bound of the subarray. We use binary search to find such left bound. Each time we compare array mid, x minus array mid, and array mid plus k minus x. This is the first element of the distance, right? Distance between first element of the subarray and x. This is distance between, is it the last element? Yeah. No, actually. Between the element to the right of the subarray and x. Right? If x is to the right of mid plus, to the right of the subarray, then x minus this must be larger than this minus x. We should set low equals mid plus 1, right? If x is to the left of the subarray, then x minus this must be smaller than array mid plus k minus x. We should set high equals mid. If they're the same, now if x is in between, inside the subarray, then the same applies, because if x minus array mid is smaller than array mid plus k minus x, then if this is smaller, right, then, which means it's closer than the left bound, yeah, so this one is further away, right? So which means it's too much to the right, right? It means that we can move to the left a little bit, right? Because it's like here, right? So we should move a little bit. We should move a little bit, and the subarray has more room to move leftwards, right? To move leftwards, because we have something on the right that's actually too big. We might have some, we can move leftwards. Similarly, otherwise, if the left is bigger than we have, otherwise the subarray has more room, might have room to move rightwards, might have. And if the same, right? If the difference is the same, we always move leftwards, because we want to favor the smaller values. Alright, with this we say low high equals 0 and then array minus k. Yeah. Just working our reach. I would actually say, because this plus k has to be, so I'm actually gonna say minus 1. But yeah, I'll just do this. I'm gonna say while low is smaller than high, mid equals low plus high divided by 2. If x minus array mid is smaller or equal to array mid plus k minus x. Right. So we're going to move more leftwards. Then we say high equals mid, else low equals mid plus 1. Right. Now we come out is going to be low, because low mid plus 1, right? Low is going to be mid plus 1, because low equals mid plus 1, which means then they come out. So it's x minus this is larger than this. So I want to move a little bit. Will you move a little bit, move too much? No, I think it's just low. So we'll just return array low to low plus k. Yeah. All right. This is faster for sure because it's just log in. One of the fastest. Oh wait, no. O plus k. So we have this. All right, that'll be it. I'll see you guys tomorrow. Adios.